Hey everybody, just got to show you the cleavage of the allyl ester. Protecting group. Okay, I don't think you've seen it before. It's in this paper, and like always, I don't like you to see stuff that looks kind of like magic and then not know about it. So we're going to talk about this. It's a pretty straightforward mechanism. All right, cleavage of an allyl ester. So let's draw an allyl ester. That's an allyl ester, right? Allyl ester. Okay, and so the cleavage reaction, and we just saw this in the PowerPoint, was that we would react this with PPH3,4 palladium 0. Okay, and the PPH3,4 is nothing. It's not really. It's a ligand that stabilizes the molecule, but it's not really it's not involved in the mechanism. So we're just going to call this all PD0. Okay, it's basically palladium 0. Okay, and then we also need some kind of nucleophile. We showed the different nucleophiles in the PowerPoint, and also I think in the paper they use aniline as their nucleophile, PHNH2, but it's just a nucleophile, it's the attack stuff. And the end result is that you get a carboxylic acid, and you get kind of like your allyl group is now attached to the nucleophile. So essentially the nucleophile is kicking off the allyl group, and palladium assists in this process. Okay, so how does it do that? It's not that hard. So you're going to start with your ester. It's an allyl ester, right? And we're going to kind of draw the allyl group, kind of poking down like that, and the X4 palladium is kind of sitting there near the allyl ester. I'm just going to do like 3 dots. So palladium sees the it sees the alkene, and what happens is a lone pair on the palladium kind of attacks this position and kicks this off, while simultaneously the double bond on the other side attacks the palladium. So it's kind of like 3 arrows, I guess, right? Palladium attacks the carbon, kicks this off. Double bond attacks palladium, and we have loss of the leaving group there, which is, you know, the carboxylic acid, right? That did it all. We just got to show it, you know, how the nucleophile is involved in this whole process. Okay, all right. So what happens now? Well, this generates the carboxylate, which grabs a proton and is done. Then the other part is, now it's kind of weird the way this looks. It's X4 palladium. X4 palladium is connected to both carbons in this sort of weird cyclic manner, and we have to distribute a positive charge. So there's a positive charge right there in the middle. Okay, that's kind of what it looks like. Palladium is talking to both carbons. There's a distributed positive charge, and there's a palladium 2. So it's actually it's changed its oxidation state. Now it's palladium 2, and okay, this thing is called a pi allyl palladium species. That's the name of this kind of weird intermediate. Okay, we're almost done, I promise you. The nucleophile then just attacks kind of there, puts electrons back on palladium and kind of back over here, and that gives you now the nucleophile, and now we're back to the weird kind of initial state where X4PD is talking back to the alkene, and then lastly the palladium goes away, minus X4PD. So the X4PD X4 again means the triphenylphosphines, PPH3s, okay? X4 PD. Okay, that's the full mechanism. The only other little tidbit to mention is, because what is this called? Allyl ester, right? Okay, let's show the whole thing. Yeah. Okay, so yeah, palladium kind of talks to the alkene, and then a couple electron movements occur, kicking off the carboxylate, and then a nucleophile attacks the palladium, and then essentially now the palladium is talking back to this alkene, and then the palladium falls off. So it's a catalyst. Palladium's a catalyst. Okay. So the only last little thing is, because in the paper they have an allyl ester, they also have an alloc group, which is very similar. There's kind of two ways you can draw an alloc group. One is if it's on a nitrogen, so this is called an alloc group. You do the same exact thing to cleave it, same. But now you get a this intermediate, which is called a carbamic acid. Carbamic acid. And you have seen this before, and you did a mechanism on this in homework 4, and what happens is it loses CO2, and then you're left with an amine. I think in homework 4 it was a Bach group, and so you have to review your homework 4 to see how this happened. I think the key's even online. Okay, and then the very last one, another variation of the alloc group, is an alcohol protecting group, right? So this is like a ester carboxylic acid protecting group. This is an amine protecting group with a nitrogen, and then this is going to be an alcohol protecting group. This is what's in the paper, and this will be on the homework assignment of how do we deprotect an alloc group on an alcohol. So this is also an alloc. It's an alloc in both situations, and it's going to be the same. And then you get an intermediate that looks like this after the allyl comes off. This is not called a carbamic acid, and of course carbamic has AM, which sounds like an amine. This is called a carbonic acid. You can guess what happens to the carbonic acid. It loses something, minus CO2. It's kind of like homework 4 again, and then you're left with the alcohol. Alright, we are done. That's all the material, and sorry I had to go through this last little bit, but it is something on the paper, and the paper's really cool, and I didn't want to have anything kind of hanging that we have not addressed. So I think we've addressed pretty much everything on this paper, otherwise that you know, you can figure out the rest, and I give you some guidance on some of the biology issues. Okay, you can also ask me email questions about this paper and the chemistry and biology and stuff. All right, cool. Well, that's the end of the lectures. See you guys, and yeah, contact me about the homework if you have questions.